So this is the station that makes the decision. So this is yeah. So this comes over here in 4S limit switch 4 S1 has to be made, and we have to press the what? Start button, right? Okay. And then it's going to extend the traverse. It's going to turn the motor on. The motor's going to go forward. Okay. And then when it passes under B1, B1 is going to detect the what? The port. This comes into input input 2.4. So that's B1. Are you okay? Then it's going to measure, then it's going to see if it's in the position to measure the height. And that's where that inductive sensor on the side comes into play. Right? Okay. And then that's going to affect input 2.3. Then it's going to hit the end, it's going to lift it up, so it can either do what? Extend it to the next module, or it can reject it. If input 2.4, I wish they would have put instead of putting the actual input, they should have put the actual sensor number over here. You see what I'm talking about? Yes or no? So instead of putting B1 over here, they actually put, instead of putting B1, they actually put input 2.4. So this says input 2.4 is not true, so it didn't get a reflected light back, right? Understand? And input 2.3 is true, which means it's the right height, right? So the port's in the right position, it's the right height. Then it's going to extend the traverse cylinder, which is going to send it up. It's going to traverse it to the next module. If input 2.4 is true, or can y'all see the thing instead of pointing up is pointing down? Can y'all see what I'm talking about? Yes or no? See here it's pointing what? Up. So up indicates it's an and. Down indicates it's an or. So it says if input 2.4 is true, which means it reflected back, so the port's not in the right position, or input 2.3 is false, which means it's what? It's the wrong height. So if the module's in the wrong position or it's the wrong height, then it's going to extend the reject cylinder, right? And it's going to reject. So this is the two conditionals, right? You'll see what it did. So I hit this spot right here, I could go either way. Now guys, this is what you got to know to do. So every one of them is going to be in a block like this. And what's required to go from each section, you're supposed to put a little dashed line there. And then onto the side, you're supposed to put what's required to go to the next module. Now why do you need to know that? Because you can program a PLC. It's called function block programming. I could take this function chart right here and program a PLC with it. This is one of the languages we can program in. But what you have to do is you basically have to do it almost just like this, right? You understand? Except the notes, this is what you would put in here in the actual function block program, and then you would put a note beside it that had all those. So this is one of the languages we can program a PLC. This is pretty cool. I was going to show you all that. So what I've done on the Festo line is I programmed the first module in 3 different languages. Structured text languages, I ain't quite got yet. So here's the flipper. So it comes up here and stepping motor. So a stepping motor is and we'll look at this a little bit. A stepping motor is a motor that moves in steps. But every step is a precise distance. So what we can do is so many steps on this means move 45 degrees. So right here, when it senses 4B1 and we press the start button, automatically this thing moves 45 degrees, which is where the sensor is for detecting the port, right? Understand that? If the port's the right size, then the stepping motor is going to go 135 degrees, so it's going to whip all the way around and it's going to be set up to traverse it to the next station. Then it's going to drop down here and it's going to traverse the traverse cylinder. The traverse cylinder is the one that moves it from station to station, right? Well, let's say it's not right. So if it's not right, if B2 was bad, then we're going to start over here. And now it's going to move it, instead of moving 135 degrees, it's going to step at what? 45 degrees. Then it's going to retract the lift cylinder because the cylinder's already up, so it's going to retract it. It's going to drop it down. Then what it's going to do? It's going to close the gripper. How did it know the gripper's closed? Because of B3. Then it's going to do what? Then it's going to extend the lift cylinder. It's going to raise it up. How does it know it's raised up? Let me blow this up. So it's going to extend it back up, 1B2. Then it's going to do what? Then it's going to rotate the gripper, right? How does it know it's rotated? 2B2. 2B2 is true. Then it's going to retract the cylinder. It's going to drop it back down. Then it's going to do what? Then it's going to open the gripper. Then what does it need to do? Then it needs to raise the thing back up. It's going to extend it, right? You understand? And then it's going to step at 90 degrees, which now it's going to line it back up, and then it's going to fall in here. So this is the way you would do what? Decision making on what it does. So depending on the sensor, it's either going to take what? This path, or it's going to take the other path. But sooner or later, it's going to do what? It's going to merge back into one. So y'all see how we do the decision making. And I wish I could show y'all this. It's really neat on writing these programs. The first time I ever got introduced to this was over in Germany. And they gave us this function chart for the first line right there, and we programmed it directly from the function chart instead of doing it in what we call ladder language. It is, but you have to make the function chart. So you got to go out there and do exactly what you did, right? You got to go in there and you got to step that sucker through everything. You got to know exactly what sensors are required to do what. You still have to do it that way. Which you have to do in ladder. But ladder is still, and we're going to show you all that, guys. Ladder is still the predominant programming language out there for PLCs. It's these newer PLCs that's added these other programming languages. So people that came up through flow charting in computer languages would like this, right? Because they're used to these flow charts. People that came up through also through hard code computer programming, they like text languages. So if you program robots, then text language is the way you program those things. Yeah, what's that? They like ladder, yeah, but a lot of people like it too because it's easy. Because a lot of people understand ladder because of the electrical trade. And then we have what we call I have to look at that. But it would be for people that comes up through digital. So you actually use symbols for ands and ors and ands and ors, and you program it that way, which is really cool. So basically, come up with methods to program a controller that makes it easy for people that comes up through different trades, right? You understand that? That deals with computers. What? I'd have to look that up. It means non-declared or something like that. Yeah. So this is called function block programming, and you can look. This is I think it's an IEEE standard. And I've got it somewhere. So this is a video. I don't know if this would show us what those letters out there mean or not. No, this is function block programming is the actual digital. So what did they call this? It's called sequential function block programming. What we're doing now. So these are the most popular. The most popular is that sequential function called. This is what we just did. I call it this is function block programming. This is digital. So this is where you do ands, ors, nands, and nors, the actual symbols for the gates. The international symbols, not from the structured text language. This is a hard-coded language. This is a text language, and a lot of programmers that come up. It's very similar to a programming language like Pascal. It's very similar to that. So people that came up programming Pascal and stuff like that, they love this stuff. From what I understand, Germans like to program in this language right here. Because they like stuff that's hard, right? And we have people that still program in Unix. You know, Unix is still the main language that runs the internet. And it is a text-based language. And people with a lot of knowledge likes that because almost nobody can do what? Almost nobody can do it. So these text languages are hard, but you have more flexibility with those languages than you do here. So there's a lot of things that we can do with this that we don't have a block to represent, right? Does that make sense? So these are the main programming languages. The one we will be playing around with this guy right here, sequential function chart. So we could almost take this sequential function chart that we've got here and we could program that into a PLC, which is really, really cool. We'll show you a little later. Like I said, if I can get it tells me my license is not valid, but it's not. And so somehow my computer's lost its license. We went to, when we went up to Tennessee, we were playing around with RS Logic 5000 and they couldn't get it installed on any of their computers. Well, Rich carried his, and guess what? I had it, so everybody was around my computer, so this computer right here. Yeah, I mean, I can't understand because we got the license for it, but for some reason it's lost the license, so I might have to call Rockwell and see if they can restore it for me. It says it can't even find it on my computer. So what we'll do next class is we're going to look at sequential charts, and we'll do the same thing with the sequential charts, which are these guys right here. If it loads. Doing something. No, this is not one. This is good too. We'll show you that. I'm looking for step charts. So there's one of these on the test. So what we'll do next class is we'll figure out how to develop a step chart. See which ones. And what they're doing is they're given two methods, and some people refer step charts, some people refer function charts, right? And so this is what we'll do next time. So y'all got any questions?